Chemical kinetics. It is the branch of chemistry which deals with the reaction rates and reaction mechanisms. Chemical reactions are of three types: those which occur very fast, those which occur at moderate speed, and those reactions which take place only very slowly. If we consider the reaction of sodium sulfate solution with a barium chloride solution, we know that on mixing these two solutions we get a white precipitate of barium sulfate immediately. So it is a very fast reaction. Now consider rusting of iron. We know that rusting of iron takes place in the presence of air and moisture. It is a very slow process. Consider hydrolysis or inversion of cane sugar to glucose and fructose. This reaction takes place at moderate speed. How can we define the speed of a reaction? It is defined as the change in the concentration of the reactant or change in the concentration of the product in unit time. We know that as a result of chemical reaction, there will be a decrease in the concentration of the reactant and an increase in the concentration of the product. Rate of disappearance of the reactant R therefore is given as decrease in concentration of the reactant R divided by time taken, or it is equal to minus delta R by delta T. And what is delta R equal to? R2 minus R1, and delta T is equal to T2 minus T1. R2 represents the concentration of the reactant at time T2 and R1 represents the molar concentration of the reactant at time T1. Now what is rate of appearance of the product P equal to? It is equal to increase in concentration of the product P divided by time taken. It is equal to delta P by delta T, where delta P is equal to P2 minus P1. P1 represents the concentration of the product at time T1 and P2 represents the molar concentration of the product P at time T2. Average rate. Average rate depends on the change in the concentration of the reactants or the products and the time taken for that change to occur. Average rate is given as equal to minus delta R by delta T, which is equal to minus of R2 minus R1 by T2 minus T1. R2 minus R1 will be negative, but we know that rate is a positive quantity. So the minus sign is introduced so that we can get rate as a positive quantity. Average rate can also be expressed in terms of the change in the concentration of the product and the time taken for that change to occur. So average rate is given as delta P by delta T, which is equal to P2 minus P1 by T2 minus T1. Average rate is therefore given as equal to minus delta R by delta T, which is equal to minus of R2 minus R1 by T2 minus T1. It is also given as equal to delta P by delta T, which is equal to P2 minus P1 by T2 minus T1. Next, we shall see what is the unit of rate. We know that rate of a reaction is given as change in the concentration of the reactants or the products and the time taken for that change to occur. So the unit of rate will be equal to mole per liter per second. If gaseous reactants and products are involved, then the unit of rate will be equal to atmosphere second raised to minus 1. What is meant by instantaneous rate? It is the rate of a reaction at a particular instant of time. We know that average rate is equal to minus delta R by delta T, which is equal to plus delta P by delta T. Now when delta T approaches 0, we get the instantaneous rate. So instantaneous rate is given as equal to minus dr by dt, which is equal to plus dp by dt. How can we determine the instantaneous rate graphically? For that, initially a graph is plotted taking time along the x-axis and the concentration of the reactant along the y-axis. A curve like this will be obtained. Now suppose The instantaneous rate has to be obtained at time t is equal to 600 seconds. For that, a tangent will be drawn which touches the curve at time t is equal to 600 seconds. The slope of this tangent gives the instantaneous rate.